Here we have a characters problem, that is we have to evaluate the given integral. So to evaluate this given integral, I have to use method of substitution. As soon as I see the problem, how can I say that I have to use method of substitution to evaluate this integration? So because I consider a particular part of the function, that is x square. What is the derivative of this x square? It's just 2x. It is in the function itself. So whenever the derivative of a part of a function is in the function itself, so we can use method of substitution to evaluate such integration. And also moreover, we can consider integration of cosine x, that is integral cosine x dx. What is its integration? I don't have to do any calculation for this one. So because already I remember that the integration of cosine x is just sine x, and we add the integral constant c. So for this one, I can easily say the answer, that is the integration of cosine x dx is just sine x. So here we have cosine function, here we have cosine function. What is the difference between these two cosine functions? So here in this cosine function, I just have single variable x over here. But in the cosine function that we have in our problem, instead of just single variable, we have x square. So this particular part troubles me. So it has to be replaced. So how can we replace this x square to get the single variable over there? So for that, we have to use method of substitution. So now what I have to do is I have to assign a new variable. That is, I have to substitute a new variable at the place of x square. So let me assign a new variable u. So for x square. Okay, so before I continue this process, I have to do one more step over here in this given integration. That is, the derivative of this x square is this 2x. So this 2x should be written together with dx. Let me write over here. Then I'm getting cosine of x square times 2x dx. Okay, now I'm going to change this complete integration to the new variable u. So when I change the complete integration to the new variable u, so instead of dx, I must have du, so that I'll be able to integrate the function with respect to u. So, but here I have u. If I want to get du, what should I do? I have to find derivative. And also here, u is the function of x. So I have to find derivative on both sides of this function with respect to x. So when I find derivative of this u with respect to x, I'm getting du over dx. And when I find derivative of this x square, I'm getting 2x. Okay, now my aim is to get du. So for that, I have to get this dx in denominator. So for that, I multiply both sides by dx. When I do so, this dx will cancel out. I'm getting du equals to 2x times dx. Okay, now let's go to the problem over here. Integral cosine. Now we can replace this x square by this u, because we have assigned this new variable u for this x square. We can plug in u for x square. And for this 2x dx, I can plug in du. So then I'm getting cosine u du. Okay, now let's integrate this one. Already we have seen that the integration of cosine x is sine x. That is, the integration of cosine x with respect to x is sine x plus c. Then what is the integration of cosine u with respect to u? So it's just sine u positive c. And u is a variable taken by us. It's not an original variable. So it has to be replaced by the original stuff. That is u equals to x square. So we can plug in this x square for u over here. Then I'm getting sine of x square positive c. So therefore, the integration of 2x times cosine of x square equals to sine of x square positive c.